Friends, welcome to my YouTube channel. In the last video, we were discussing about encoding in machine learning and different types of variables in machine learning, like categorical variables and ordinal variables. All those aspects we discussed in the last video. This is a quote from Mother Teresa. There are no great things, only small things with great love. Happy are those. Let's continue with the encoding part. In this video, I am going to discuss discuss on label encoding. This is the 12th video on feature engineering. You can go to the playlist feature engineering and watch the other videos as well. Let's continue. This is a very nice diagram. It will give you the classification of data in machine learning. In machine learning, data is classified into categorical and numerical data. Categorical data is again classified into nominal and ordinal data. Numerical data or quantitative data is classified into discrete and continuous data. This diagram will be very helpful for you. Now, what is categorical data? It's also known as qualitative data. Categorical variables represent types of data which may be divided into groups. Simple example, sex is an example, race, age group. Sex means male or female, then like that we can classify it. Such data we call it as categorical data. Again, if from this diagram you understood, categorical data is again classified into nominal and ordinal data. I am talking about nominal data as well. Nominal data is defined as data that is used for naming or labeling variables without any quantitative value. Nominal data is named data which can be separated into discrete categories which do not overlap. A common example of nominal data is gender. It can be male and female, right? Other examples include eye color and hair color. Fine. This is ordinal data. Ordinal data is a categorical statistical data type where the variables have natural ordered categories. It is ordered and the distances between the categories is not known. This is very important. This is ordered categories. Example, if you want socio-economic status, that is low income, middle income, high income. Educational level, it can be high school, BS, MS, PhD. Income level less than 50k, 50k to 100k or over 100k. Satisfaction rating, it can be extremely dislike, neutral, like, extremely like that. Ordinal data, it is classified. See, encoding of, so we usually do the encoding of categorical variables. The reason is machine learning algorithms cannot handle categorical variables unless we convert them into numerical values. And algorithms performance depends on how categorical variables are encoded as well. The performance of the algorithms also depends on the categorical variables, how it is encoded. There are many algorithms that support, machine learning algorithms, supervised and unsupervised machine learning algorithms that support categorical values without encoding as well. Categorical encoding is a process of converting categories into numbers. Categories are converted into numbers. That's what we do in categorical encoding. Different types of encoding techniques, if you one hot encoding, label encoding, ordinal encoding, binary encoding, frequency encoding, these are all different types of encoding techniques we usually use in machine learning. In this video I am going to discuss specifically about label encoding and how we can implement this label encoding in a Python program. See, label encoding. In machine learning, we usually deal with datasets which contains multiple labels. These labels can be in the form of words or numbers. To make the data understandable or in human readable form, the training data is often labeled in words. Label encoding refers to converting the labels into numeric form so as to convert it into machine readable form. Machine learning algorithms can then decide in a better way on how those labels must be operated. That's the label encoding. This is a simple example. We have the country, age, and salary. This is the data input data we have. This data is to be, we have to do the label encoding with the data. So India, Australia, Japan, Australia, Japan, this is the age range it's given here, and the salary also, the corresponding to the countries, the salary is also given. See, now the output when we do the label encoding using a Python program, see, this is the output we will get. Country 0, sorry, 10202, because it's here you can see Australia is repeated here, so you will get it as 10202. Then age and salary, everything you will be getting it here. So this is the way you encode the application, encode the, the data it's given on the categorical data. So I will show you, before that I will show, before discussing the limitations, I will show you a program how we can run the label encoding using that program. I am using the Spyder IDE. You can get it from the Anaconda. So this is the input CSV file I am using. I can show it here. This is the file I am using it here. Here you have country, age, salary, India, Australia, Japan, Australia, age is given, salary is also given. I have saved in the file in this location. You can see it here. It's, yeah, this is the file. See, label underscore score. So this is the file I have, it's here, it's a CSV file. You can see here label, it's for label encoding, label underscore score. So the file, this is the file. Now I am running the program in the Spyder IDE. So you can, see here it is, import numby as in, here we are using only pandas, numby is not needed here. Import pandas as PD. From sklearn we are importing pre-processing, and I am reading the data from this location, dcolon tatumasi algorithms programs. It's reading. After that I am printing the data. Now I am using the label encoder, pre-processing dot label encoder data. Then fit underscore transform method from label encoder I am calling for the for the column country. So that's what I have done here. Then I am printing the data here. So you can, I will run the program. You can see it here. See, this is the input data we have given. This is the CSV file. You can see here India, Australia, Japan, Australia, Japan. After encoding, you can see here 10202, because it is, after encoding you will get this result as like this. Same, 10202. The salary is also given, everything it's given, it's encoded with these values 10202 and everything. This is the way we do the encoding here. And you can see the age, it is Australia, it's repeating, so it is 0. The age is 34 and corresponding it's 35. Salary is also, it is 65,000 and 45,000. You can see it here. Since how, why two zeros, that zero represent Australia, since it is repeating, and the corresponding age and salary is given there. So you understood the program. Now I am again coming back to the limitations of label encoding. Label encoding convert data in machine readable form, but it assigns a unique number starting from, you have seen it, 0 to each class of data. This may lead to the generation of priority issue in training of data sets. A label with high value may be considered to have high priority than a label having low value. In the above example, the country names do not have an order or rank. But when label encoding is performed, the country names are ranked based on the alphabets. Due to this, there is a very high probability that the model captures the relationship between the countries. To avoid this, we come up with the concept of one-hot encoding. You can watch the video for one-hot encoding as well. It's there in the playlist. You can watch that video as well. So that's another type of encoding, that is one-hot encoding. So you understood label encoding convert the data in machine learning. So it's we are using unique numbers. This may lead to the generation of priority issue. This is the most important point in training of data sets. A label with high value be considered to have high priority. And in the above example as well, we have used country names that do not have an order or rank, but when label encoding is performed, the country names are ranked based on the alphabets. Due to this, there is a very high probability that the model captures the relationship between countries. That is, it's a problem. To avoid this, we have come up with one-hot encoding. You can watch the video for one-hot encoding as well in the playlist Feature Engineering. That's all. Thanks for watching. Please like, share, and subscribe. Thanks a lot.